Okay, so we're going to pick up where we left off in class. And first of all, I just want to say sorry to those of you who tried several times to explain to me that there are not, whatever I said, 49 problems if we do 1 through 46 odds and 22, 30, and 42. I was just, I don't know what was wrong with me. But anyway, just want to apologize. I believe, if I have now counted correctly, that there are 26 problems that we'll do in section 1.5. I am so sorry. Anyway, moving on. So let's go ahead and do this boat problem again, just so to make sure you understood what I was talking about. So anyway, Trent takes his boat 6 miles downstream with a 1.5 mile an hour current. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water. So we remember that when you are driving a boat in a current, if you're going against the current, your boat slows down. If you're going with the current, your boat speeds up. So he goes 6 miles downstream. So we'll just write that over here. Downstream, rate times time equals distance. And when he's going downstream, his speed, his rate is the boat plus the current, which is 1.5 miles an hour. And then we'll just say his time is t and his distance is 6. And then when he goes up the river, his rate is b minus 1.5. It slows the boat down because it's pushing against the boat. And so then in the problem it says that it takes an hour longer to go up the river, so his time is t plus 1 in that situation, and the distance is still 6. He goes down the river and then he goes back up. So we have from the down the river part, we have b plus 1.5 times t equals 6. And up the river, we have b minus 1.5 times t plus 1 equals 6. So what I would do first then is solve for t in this first equation. T equals 6 over b plus 1.5. Then plug that into the second equation right there for t. All right, so we've got b minus 1.5 times 6 over b plus 1.5 plus 1 equals 6. Okay, so if we multiply this together, we would multiply this by the first fraction. So we would have 6 times b minus 1.5 over b plus 1.5. And then we would multiply it by the 1. So we would have plus b minus 1.5 equals 6. Okay, so we can distribute the 6 in the numerator here, and we'll have 6b minus 9 over b plus 1.5. And then I will move the b and the negative 1.5 to the other side of the equation. So we're going to have negative b plus 7.5. And then I'm going to multiply both sides of the equation by b plus 1.5, so that the left side will be 6b minus 9, and the right side will be b plus 1.5 times negative b plus 7.5. So you can see that we're getting ready to have a quadratic equation. So 6b minus 9 equals b squared, negative b squared, plus 7.5b minus 1.5b plus 11.25. So what happens is you've got 7.5b on the right side minus 1.5b, so that is 6b. So the 6b cancels out, and you just end up with b squared on the right, and then add 9 on both sides, and you have 20.25. So b, normally we would say plus or minus, but since this is a boat's speed, it can't be negative. So it's just going to be the square root of 20.25, And if you punch that into your calculator, it's not about 4.5, it is 4.5. So that's 4.5 miles per hour for the rate of the boat in still water. Absolute value equations. Given a non-negative real number k, the generic absolute value equation, absolute value of u equals k, can be solved directly from the definition of absolute value. Remember, absolute value of u equals u if u is greater than or equal to 0, and it equals negative u if u is less than 0. So that's just saying that if you're taking the absolute value of a variable and you don't know what it is, if you know it's positive, its absolute value just equals what it is, because the absolute value of 3 is 3, the absolute value of 2 is 2. If it's positive or 0, its absolute value is just whatever it is. But if it's negative, if u is a negative number, it's less than 0, then its absolute value is the opposite of whatever it is. So if you have the absolute value of negative 2, that equals positive 2, the opposite. Okay, so thus, the absolute value of u equals k means that u equals k or u equals negative k. Solving for u, we have u equals k or u equals negative k. It'll make more sense. Reading these kinds of definitions is always confusing. So let k be a non-negative real number. 1, the absolute value of k, the absolute value of u equals k is equivalent to u equals k or u equals negative k. The absolute value of u is 0 is equivalent to u equals 0. The absolute value of u equals negative k has no solution because you're never going to get a negative number when you say the absolute value of u equals something. If that thing is negative, there's no such number that you can put inside of an absolute value that's going to give you a negative number. And then the absolute value of u equals the absolute value of w is equivalent to saying u equals w or u equals the opposite of w. And like I said, memorizing this is not the way to go. It's better if you just understand what it means. So let's look at some situations here. Okay, solve the equations. Always start by isolating the absolute value expression. Okay, so in this first problem, we've got 2 times the absolute value of the quantity 3 minus 2t equals 6. The first thing you have to do before you try to do anything here is isolate the absolute value, get it completely by itself. So you're going to divide both sides of the equation by 2. The absolute value of 3 minus 2t equals 3. All right, well, what does that mean? If the absolute value of this stuff is equal to 3, then this stuff is either 3 or it's negative 3. One or the other. So either 3 minus 2t is 3 or 3 minus 2t is negative 3. That's the only way that its absolute value could possibly be 3. So this is how you set this problem up. You just say, well, either that stuff is 3 or it's negative 3. That's the only way its absolute value could possibly be 3. So now you just solve. Here you subtract 3 on both sides and you get negative 2t is 0, so t, is 0. On this one, you can subtract 3 on both sides and you get negative 2t equals negative 6, so t equals 3. And just to be sure that you did it correctly, you can just jump back super quick and plug it back into the original equation. So if you put 0 in the original equation here, you'd have 2 times the absolute value of 3 minus 0, which would be 2 times the absolute value of 3, which is definitely 6. And then if you put in t equals 3, you put that in, you've got 2 times 3 minus 6, and that is 2 times the absolute value of negative 3. 2 times the absolute value of negative 3 is 2 times 3, which is also 6, so it works. All right, so the best thing to do is just to realize that if the absolute value of some quantity is equal to some positive number, then the quantity inside the absolute value must be that actual number or its opposite. All right, so looking at B here, first thing we have to do again is isolate the absolute value. So we're going to subtract 8 on both sides, and we'll have negative 6 equals the absolute value of 7 minus 3. That's impossible. Anything you put in here for W when you take the absolute value of it, it's going to be a positive number. It can't equal -6. So this would be the empty set. No such thing, no solution. There is no value that you can put in for W and take the absolute value of 7W minus 3 and somehow get a negative number. That can't happen. So that would be the empty set. Okay, sometimes you're going to have two absolute values, and this is very similar to just having one absolute value, because if the absolute value of 2x minus 5 is equal to the absolute value of x plus 1, then 2x minus 5 must either equal x plus 1 or it must equal the opposite of x plus 1. That's the only way their absolute values could possibly be equal, would be if either they are the same, 2x minus 5 equals x plus 1, or their opposites, 2x minus 5 is the opposite of x plus 1. So now we just solve. Get x by itself, subtract x on both sides, and you have x equals 6 after you add 5 on both sides. And then here you got 2x minus 5 equals negative x minus 1. Add x on both sides, add 5 on both sides, and you get 3x equals 4, so x equals 4/3. And if you check that back in the original problem, you would have, if you put 6 into the original equation, you'd have 12 minus 5, absolute value of 12 minus 5 is equal to the absolute value of 6 plus 1, and 12 minus 5 is 7. Absolute value of 7 equals the absolute value of 7. So yeah, that works. 4/3, if you put that in, you're going to have the absolute value of 8/3 minus 5 is equal to the absolute value of 4/3 plus 1, and 8/3 minus 15/3 is going to be negative 7/3, and 4/3 plus 3/3 is 7/3. So you can see that in that case the two quantities are opposite, but their absolute values are definitely equal. So on this next example, we have the absolute value of 6 minus x equals the absolute value of x minus 6. And what that means is that either 6 minus x is equal to x minus 6, or 6 minus x is equal to the opposite of x minus 6. So for this first equation, you can subtract 6 on both sides and subtract x on both sides, and you'll have negative 2x equals negative 12, so x equals 6. And then for the second equation over here, you've got 6 minus x equals negative x plus 6, and you can see that everything cancels, and you just end up with 0 equals 0. And 0 equals 0 is definitely true. It's always true. So in that case, any number will work in this equation. So the solution set is just the real numbers. Oops. The real numbers. Because, and you can try it. 6 minus 1 is 5. 1 minus 6 is negative 5. 6 minus 2 is 4. 2 minus 6 is negative 4. So any number you put in there, you're going to get the same absolute value on both sides. Okay, solving radical equations. If you have the cube root of x equals 5, then you would cube both sides to find x. So that would tell me that x equals 125. Now, remember that whenever you square both sides of an equation, you have to check your answer. So, I mean, clearly this is correct. The cube root of 125 is 5. That was a very simple equation where you can quickly see that it absolutely is true. Over here, when you solve a radical equation, like I said, you must check your answer. If you square both sides of this equation, you're going to get x equals 100. And clearly, if you put 100 in here for x, you don't get negative 10, you get 10. So this is not a solution. All right, so solve this equation. The first thing you do is always start by isolating the radical. So you're going to get the radical all by itself, and you're going to add 4 to both sides, so you can do that. You'll have x plus 10, square root of x plus 10 equals 4 plus x. Now you're going to square both sides. Left side, when you square a square root, you just get whatever is the number that's under there. Then when you square 4 plus x quantity squared, you do not get 16 plus x squared. Definitely not. You get 16 plus 8x plus 8 plus x squared. So remember, when you have something like this, it's not 4 squared plus x squared, it's 4 plus x times 4 plus x. So don't think you can distribute that square. You can't do that. Okay, so this is a quadratic, clearly, and so you want to get everything on one side. I'm going to move everything to the right side, which is going to make it all positive. So it will be x squared plus 7x plus 6 equals 0. And so you can factor this to x plus 1, x plus 6. And so x would be -1 or x would be -6. But you have to check those in the original equation. So if I put -1 into this original equation for x, I'm going to have the square root of -1 plus 10 minus 4 is supposed to equal -1. Does it? Let's see. Square root of -1 plus 10 is the square root of 9 minus 4. Does that equal -1? 3 minus 4. Yes, it does equal -1. So that one's right. How about -6? I'm going to put -6 in for x. So -6 plus 10 minus 4 equals -6. So that's going to be the square root of 4 minus 4 is supposed to equal -6. 2 minus 4 does not equal -6. So this is not a solution to this equation. Just remember, whenever you square both sides of an equation, whenever you cube both sides of an equation, you might be adding solutions that don't actually work in the original equation. This equation has 2 radicals in it, and so what we're going to have to do now is we're going to have to isolate one radical at a time and square both sides. So first I'll isolate the square root of m minus 1, so I will have the square root of m minus 1 equals the square root of 3m plus 1 minus 2. And so now I'll square both sides. So when I square the left side, the radical goes away, and I have m minus 1. When I square the right side, remember, a minus b, quantity squared, is equal to a squared minus 2ab plus b squared. So I'm going to square this binomial on the left. So the first thing squared is 3m plus 1, then minus 2ab plus b squared, which is 4. So m minus 1 equals 3m plus 1 minus 4 times the square root of 3m plus 1 plus 4. Now I'm going to isolate the other radical. So I'm going to just move everything over to the left side. Well, first I'll do this. On the right side, I've got 3m plus 5 minus 4 times the square root of 3m plus 1. So I'm going to subtract 3m and subtract 5 on both sides. So I'll have negative 2m on the left minus 6 is equal to negative 4 times 3m plus 1. Square root of 3m plus 1. Now normally I would divide both sides by negative 4 before I square both sides again. But since that would make all kinds of fractions on the left side, I don't want to do that. I'm just going to go ahead and square both sides now. It's not hard to do since this is just a factor over here of negative 4. So if I square both sides now, I'm going to get, again, don't forget that you're dealing with a minus b quantity squared. So you've got a squared, so 4m squared minus 2ab plus b squared, so 36, equals 16 times 3m plus 1. So on the left side, I've got 4m squared plus 4 times 6 is 24m plus 36 equals 48m plus 16. And so now I'm going to subtract, well, let's see, I'll just get everything on the left side. So 4m squared minus 24m plus 20 equals 0. Now I am going to factor out a 4. So 4 times m squared minus 6m plus 5 equals 0. And so now I can factor this and I've got m minus 5, m minus 1. That means that m is either 5 or m is equal to 1. Now I'm going to try those in the original equation. So if I put 5 in, I'm going to have 5 minus 1 minus square root of 15 plus 1. That's supposed to equal negative 2. So that is square root of 4 is 2. Minus square root of 16 is 4. 2 minus 4 does equal negative 2. So 5 works. Now I will go back up there and put 1 in. I'll just do it down here on the right side for m. So square root of 1 minus 1 minus the square root of 3 times 1 plus 1. That's supposed to equal negative 2. So square root of 0 minus the square root of 4 is supposed to equal negative 2. 0 minus 2 does equal negative 2. So that works also. So the solution set here for m is going to be 5 and 1. Okay, let's think about rational exponents. What do they mean? Well, when you have an exponent on a base and it is a fractional exponent, a rational exponent, the top number is the power and the denominator of that exponent is the root. So x to the 2/3 power means the cube root of x squared. So whenever you have a fractional exponent, the numerator is the power that you're raising that base to, and the denominator is the root you're taking. So in this problem, you've got 2 times x plus 1 to the 2/3 equals 8. First thing to do is to divide both sides by 2 and get that that quantity that is raised to the 2/3 power completely by itself. So divide by 2 and you get this. Now, what does it mean, x plus 1 raised to the 2/3 power? It means the cube root of x plus 1 squared. So this is what you have, and now you can cube both sides. So you're going to raise both sides to the 3rd power, and that's going to make the radical sign go away, and you will just have x plus 1 quantity squared equals 4 cubed, which is 64. And now you have to take the square root on both sides. So you're going to have x plus 1 equals, but remember, whenever you take the square root on both sides of an equation, you have to put plus or minus. So plus or minus the square root of 64. So x plus 1 is equal to plus or minus 8. So x is equal to negative 1 plus or minus 8. Negative 1 plus 8 is 7. Negative 1 minus 8 is negative 9. So since we did cube both sides of that equation, we need to go back and check and see if these work. So if I go back to the original equation and I put in 7 for x, I'll have 2 times 7 plus 1 to the 2/3 power. That is 2 times 8 to the 2/3. So that means that I am taking the cube root of 8, which is 2, and I'm squaring that. So 2 times 2 is 4, times 2 is 8. So you can see that that does work in the original equation. Now, so 7 works. Let's try negative 9. If I go back to the original equation and I put in negative 9, I'm going to have 2 times negative 9 plus 1 to the 2/3 power, and that's going to be 2 times negative 8 to the 2/3 power. The cube root of negative 8 is negative 2, and then I'm going to square that. So that's going to be 2 times 4, which is also 8. So both of these work. So the solution set is 7 and negative 9. Okay, sometimes you will see an equation that is in the form of a quadratic equation, but it is a little more complicated. And you can use this idea of substitution to solve the equation in a more simple way and then put the original value back in when you're done. So here you can see on this first example, you've got 2 plus 3 over x, that quantity squared, minus 2 plus 3 over x, same quantity, minus 12 equals 0. So you've got something squared minus that same thing and then minus a constant. That looks like a quadratic equation. So if we want to substitute, we could let u equal 2 plus 3 over x. And then we could solve the equation u squared, so that's 2 plus 3 over x squared, minus u, 2 plus 3 over x, minus 12 equals 0. We solve this equation, then we will get whatever u is, and then we can plug 2 plus 3 over x back into u and see what the solution is to the original equation. It'll make more sense when we do an actual example, but if you look at the second one, it also, when you first look at it, looks like a quadratic, but it's a little bit different. But you can see that you've got 2w to the 2/3 minus 3w to the 1/3 minus 20 equals 0. Looks like a quadratic trinomial. So if you substituted, if you let u equal w to the 1/3, then this equation here is what this equation is right here, because it's 2u squared, so 2w to the 2/3, minus 3u, so 3w to the 1/3, minus 20 equals 0. So what you're doing is you're substituting a more complicated thing for a simpler thing, so that you can do all the algebra and all the solving with the simple thing, and once you're done, you can put that back in and figure out what the solution to the more complicated equation is. So let's just do an example. All right, so here you've got 2x squared minus 3, that whole thing squared, plus 36 times 2x squared minus 3 plus 35 equals 0. Well, if I say that u is equal to 2x squared minus 3, this stuff in the parentheses, then I can rewrite my equation as u squared plus 36u plus 35 equals 0. So I'm basically just changing the name of this ugly thing, u squared, u, and making it something easy to deal with, and then later when I'm done, I'll put back the messy thing. All right, so now I can just solve this easy equation here, u squared plus 36u plus 35 equals 0, and I can easily factor this to u plus 35, u plus 1, and that means that if u plus 35 times u plus 1 equals 0, that means that either u plus 35 is 0 or u plus 1 is 0. So u is negative 35 or u is negative 1. Now that I've solved it, I'll go ahead and put this back in for u and see what I get for x. So here we go. We're going to put 2x squared minus 3 back in for u. That equals negative 35. And then I'll add 3 on both sides, and I'll have 2x squared equals negative 32. So if I divide both sides by 2, I'm going to get x squared equals negative 16. And then if I take the square root on both sides, I'm going to have x equals plus or minus the square root of 16i, which is just plus or minus 4i. So that's one part of the solution. And then up here I've got u equals negative 1. So again, I'm going to put 2x squared plus 2x squared minus 3 back in for u. So 2x squared minus 3 equals negative 1. And then I'm going to add 3 on both sides. 2x squared equals 2. So x squared equals 1. So x equals plus or minus 1. So for the solution set, you've got plus or minus 1, and you've got plus or minus 4i for x. And I'm not going to go back and check that in the original equation, but they all work. Okay, here's another one that looks like a quadratic. If I get everything on one side, 2w to the 2/3 minus 3w to the 1/3 minus 20 equals 0. I can notice this looks like a quadratic if I change w to the 1/3, if I call that u. So w to the 1/3, if I call that u, then this equation is 2u squared minus 3u minus 20 equals 0. And that's an easier equation to deal with. So I can factor this. I might stick it into quadratic formula, but it can be factored, so I like to do it that way. I want to find two numbers that multiply together, give me negative 20, and will help this all add up to negative 3u for the middle term. And so if I try negative 4 and 5, that's going to give me negative 8 plus 5, which is what I want. So that works. So I've got u could be negative 5 halves, or u could be 4. So I found out what u is. Now I need to go ahead and plug that back in. I need to put w to the 1/3 wherever I see a u. So w to the 1/3 power equals negative 5 over 2, and w to the 1/3 power equals 4. I'm going to cube both sides here, so w is equal to negative 125 over 8, and then I'll cube both sides of the other equation, and I'll have w equals 64. So if I put these values back into the original equation, let's see what happens. I'm going to put negative 125 over 8 in for w, so 2 times negative 125 over 8 to the 2/3 power equals 3 times negative 125 over 8 to the 1/3 power plus 20. So this will be 2 times, if I take the cube root of negative 125 over 8, I'm going to get negative 5 over 2, and I'm going to square that. And then if I take the 1/3 power of negative 125 over 8, I still get negative 5 over 2 plus 20. So on the left side now, I have 2 times negative 5 squared is 25, and 2 squared is 4. And then over here I've got negative 15 halves plus 20. So I have 25 over 2 equals negative 15 over 2 plus 20 is 40 over 2. So that is 25 over 2. So that works. So this works. Okay, now if I put w back into if I put w equals 64 back into the original equation, I'm going to have 2 times 64 to the 2/3 equals 3 times 64 to the 1/3 plus 20. So that is 2 times 64 to the 1/3 is 4, squared is 16. So 2 times 16 equals 3 times 64 to the 1/3 is 4 plus 20. So that means the left side is 32 and the right side is 12 plus 20, which is also 32. So 64 also works. So my solution set for w is negative 125 over 8 and 64.